Hello guys. Okay, I'm really sorry I kept you guys waiting. I just had some problem on my own end. Okay, so like I said, today we are going to be talking about IoT. So I'm going to be introducing you guys to IoT. And the full meaning of IoT is Internet of Things, where you have to connect physical devices together over the internet, over a network. Okay. Now, so many people do not know anything about IoT. IoT is actually, it has a very good future, especially in our country, Nigeria. So many people do not know about this field. So many people have not really looked into this field. So I'm just going to introduce you guys to IoT today, and then um, we can build a simple IoT project just to see how IoT interacts with devices and to see how IoT works. Please, if you're with me, you can leave a comment behind. Okay, guys. So, like I said, IoT is all about connecting devices together, connecting physical devices together so that they can be able to interact with each other. So, like I said, you can use Python, you can use C++ to develop an IoT application, to build an IoT project. Okay. Now, there are three main components of IoT. The first one is microcontroller units, the second one is sensors, and the third one is cloud. Okay, so the sensor is just like something that converts physical other kinds of electric energy into electric signal. So it's just like sound sensor that takes sound from the environment, convert it into electric signal, and then send it to the microcontroller for processing. Now the microcontroller is the brain of the whole thing. Okay, it's just like a computer on its own that can process something. This thing you're seeing here, this is what I use for every of my work. This is what I use for every of my work. This is Arduino. So this has the microcontroller inside. Now this is just like a computer where I connect every other device. I upload my code here, and this thing, while plugged in power, it works automatically. It runs the code inside it automatically. So whatever it receives, then it gives out based on what is connected on it. Okay, so assuming I want to run a project where I like want to detect light and act based on the amount of light I detect, then I have to connect the light sensor, that is photoresistor, and every other thing to this. So, like I said, there's also something we call actuators. Now, actuators are like the devices that the microcontroller talk to, respond to when it receives a signal from the sensor. Okay, you might want to you might want to say, once this thing receive this amount of light, once the sensor receive this amount of light, then send a signal to the microcontroller, then let the microcontroller turn a bulb on. So the bulb is like the actuator, is what is acting. So you received a signal from the sensor and you are acting through the bulb or whatever you're acting with. Okay, then cloud computing. So IoT stores data every seconds. So you can store them in the cloud. This is the best way to store IoT data. You can store them in the cloud, and they produce live data all the time. So based on this data, you can then act with the response. Now, IoT can be used in so many ways. Okay, it's just like in agricultural system. You can use IoT to detect when there is less amount of, let me say, when you need to irrigate the soil, okay, when there is no water in the soil, you can use IoT sensor to dictate that, and then you act maybe by automatically turning water on so that the water can splash on the crops or wherever. Then in medical system too, it can be IoT can be installed on a patient, on a diabetic patient, so that it will be reading real life data at every seconds. Is telling you, is sending information to the doctors, information like, this is this person's blood sugar at the moment. Then if the blood sugar is high, the doctors can act based on what you program the device to do. It can act if the blood sugar is high, or a temperature system. These are just things you can use it for in medical field. Okay, then in security systems too, you can use it for, let's say, automatic door locks and all of that, password systems, to automatically program a safe and all of that. So now, how does IoT work? IoT works, like what I already said. There are some, like I said, the main brain behind IoT is the microcontroller board, and there are so many of them. You can use Arduino, you can use Raspberry Pi, you can use ESP8266 or ESP32, depending on the one you want to use. And each of them have the platform they work best with. It's just like Arduino. Arduino has its own programming language. It works best with its own programming language. Now, Raspberry Pi also work with Python. Okay, Raspberry Pi also work with Python. It's very good with Python. If you want to program using Python, then you have to use Raspberry Pi. So the projects I've been making use of this Arduino. Okay, so I'm just going to tell you a bit of how this works. Now, like I already talked about the sensors, there are so many kinds of sensors, okay, depending on what you want to do. Just like what you're seeing here, this is a heat sensor. So it detects when there is fire around based on the amount of heat signal that the thing is receiving. So it detects it and then send information to this board. So all you have to do is to connect this sensor to this board. And then this sensor detects the amount of heat is receiving, okay? Then in your code, you can say if the heat is bigger than this number, is greater than this number, maybe it should act. Maybe by turning water on, because yeah, since it's more than this, there is a fire. We are sure there is a fire. So you can act by turning water on or something equivalent to that. Um, I also have another kind of sensor here. Please, if you have any question, you can just type. So this is ultrasonic sensor. This detects objects, the distance between objects. So it just, when an object is in front of it, it just detects how many meters far away is this object from me. Okay, so when we use this, we can just use this with this particular sensor. Maybe we want to do something like automatic door opener, sorry. So when we detect that someone is very close to the door, maybe like less than 10 meters close to the door, then this will send a signal to the microcontroller, and then we act, maybe by pushing the door to open for the person, or just anything you want to do. But that is the function of this ultrasonic sensor. So IoT is based on sensors, actuators, data collection. Okay. Then I have this. This is a motion sensor. The last project I did, I used this for it. Okay, so this just detects a moving body. It detects that something is moving. So when it detects it, it sends information to this microcontroller board. And then the microcontroller, based on the code inside it, can then act. Okay, so now, IoT is very important. and it is part of AI. Okay, so this just enables devices to be smart. They can work on its own without you telling them to do it. It's just like when you walk into a room. Your device already know that, yeah, you walked into this room and you need this light. You don't need to come and start on the light or offing the light. It's just intelligent on its own. It detects that someone is inside this room and someone needs this light. Okay. Okay, Kosiso Chukwumezo, you asked for my email address. Okay, you can use Okereke Helen Ugoeze at gmail.com or helen.flossitech.com. Okay, so let's talk about IoT in association with AI. Okay, like I said, IoT collects lots of data. Just every second, the sensors there, they are collecting real-time data. And assuming you're storing on the cloud, you are sending all this data to the cloud. Okay, now how does AI, artificial intelligence, machine learning come into this? Machine learning has to do with data. So computers just learn on its own based on the data stored on it. Okay, so in a IoT in association with AI can just be like, maybe you want to keep producing data about this particular patient. Okay, so the computer will act on its own whenever maybe the patient's um blood sugar is higher than this. Maybe the patient's blood sugar have not reached this level before. Yeah, it's collecting real-time data all the time. So it has data for the patient's record since. So you can just act maybe when the patient's sugar level is higher than normal, is higher than it has always been. So it sends a signal to the microcontroller and then it acts. This is IoT in association with machine learning. Okay. So getting started with Arduino. Like I said, this is the Arduino board. Sorry, please, if you can see the board well, please leave a comment. If you can see the board well, leave a comment. Okay, great. Okay, Kosi Sochukwu asked if there are different kinds of this board. Like I already said, this is a microcontroller board. It has the microcontroller inside. So there are so many kinds of microcontroller board, okay? We have Raspberry Pi, we have Arduino, and Arduino is compatible with the Arduino programming language. So assuming I want to write into this board now, because I actually write my code and then I upload it into the board. So assuming I want to write into this board now, then I have to use Arduino programming language, which is C++ syntax. Okay, so Arduino programming language was built from C++. So if you know C++ well, then you can be able to. So even with this Arduino itself, there are different kinds of Arduino. Okay, we have Arduino Uno, we have Arduino Nano. Okay, so we have Arduino Mega, so many of them, and they just have different designs. They have different designs. So the one I'm using now is Arduino Uno. That is this particular Arduino board I have in my hand. Okay, so I'm just going to like introduce this Arduino Uno to you guys. Tell you, I know most of you are seeing this and you don't even understand what you're seeing. Okay, wisdom, like I said, what works on Arduino is Arduino programming language, C++ syntax. Arduino programming language was built on C++. So it just uses C++ syntax. Then you can now learn the other Arduino keywords. Okay. So that is why when you guys ask me the language I use, I just tell you guys C++. I know lots of you have not heard about Arduino programming language. Okay, but that is the language you use in writing this, but it is built from C++. Okay, so like I was saying, you guys are seeing this board and I know you don't understand what you're seeing here. Okay, so I'm just going to introduce you guys and help you to understand how this board works, how you can be able to connect this board to your sensors, actuators, and all of that. Okay, so right here, I'm sure you're seeing numbers. You're seeing numbers. You're seeing numbers from 0 to 13. Okay, so these numbers are not just there for fancy. These are the numbers you use for your actuators, for your sensors and actuators. And these are pins. Each pin has its own number. So assuming I connect photoresistor to pin 5. This is pin 5. Okay. Now this is it. I have what we call jumper wires. These jumper wires now is used to connect this. I can just get one out of it, and then this is pin 5 here. I just connected this jumper wire to the Arduino. And then I can connect the other end of this jumper wire to something else. Maybe if it's ultrasonic sensor I want to use, then I will connect it to the ultrasonic sensor. Okay, now let's just learn about these sensors. Okay, so what we are going to try out today, we are going to make use of the photoresistor. This is the photoresistor. Okay, as you can see, sorry, let me just introduce you guys to the types of jumper wires we have, because this thing you're seeing here now, we can't use this jumper wire because there is no way to connect it except you want to solder. Okay, so I'll just introduce you guys to the types of jumper wires we have. We have 3 types of jumper wires. We have male to male, which is what you're seeing here now. Male to male, the pin is out. Then we have male to female. So this is female, this is male. You can connect the male into the female, just like this. Okay. Then we also have female to female. The female to female has this end. Just have this in the 2 ends. Though I don't have female to female here. I just have male to male and then male to female. Okay, now This is also what we are going to use for our project tonight, just to show you how sensor receives data, sends it to the microcontroller, and then the microcontroller acts. So this is what we are going to be acting on. This is just like a traffic light. Okay. Now each of these have pins, and these pins are labeled. So if you can see very well from what I'm holding, the first one is GND, the second one is R, we have Y, and we have G. Okay, so R is red. So if we and it has 4 pins. This one is GND, this one is red, this one is green. Sorry, this one is yellow, and this one is green. Okay, so if I connect this particular pin now to pin 5 of the Arduino, just like this. I'm going to use male to female since this is a male something. So now this is green. If I connect green, this is the Arduino. If I connect green to pin 5 of the Arduino, yeah, this is pin 5. I just connected green to pin 5 of Arduino now. So each time I'm sending signal, I'm sending something, I'm trying to act on this, is going to use this pin I connected it to. So in my code, I will say that green light is pin 5. Okay, just to make it understand, green light is pin 5. So whenever I want to on green light, I will have to send a command to pin 5 of this Arduino. So whenever I send a command to pin 5, that means I'm talking about what is connected to pin 5, and that is green light, and this green light will on. Okay, now this GND, the GND pin is not just there for it to be there. Okay, so GND is the negative. I know in electricity we always have negative and positive. So for you to be able to do this, you need to understand the basic part of electricity. You need to understand positive, negative, resistors, and all of that. So we will be using resistors too for our project. Now resistors is just like the name applies. It resists the amount of the voltage of current it's getting. Okay, so it just resists the voltage of current it's getting. For example, the photoresistor we have here is supposed to need like 3 volts to on. Okay, 3 volts to function. But Arduino board already has the already have resistor inside of it. So we don't need to come and start regulating the amount of current the Arduino is taking. Okay, so once I connect the Arduino to power, no matter how many volts of power the power source is given, Arduino will just take 5 volts. Okay, if it takes more than 5 volts, it will blow up. So it's already programmed in a way that the resistors are already inside the board. That is for the Arduino board itself. So the resistors are already inside the board, and whenever it's connected to power source, it just takes 5 volts and power itself. Now this is supposed to take 3 point something volts to power. But Arduino here is taking 5 volts, which means Arduino is also giving out the 5 volts that it's taking. So if I'm to power this, I have to use a resistor. So if I'm to power this, I have to use a resistor because I'm expecting 3 point something volts to power, and this is giving 5 volts. If I don't use a resistor, it's going to collect the whole 5 volts from this, and this will heat up and spoil. Okay, it will heat up and spoil because it's collecting more than expected. So I'll just use resistor to regulate the amount of voltage this thing is taking. That is the function of resistors, and we will see it a lot as you go, as you continue handling IoT projects. You're going to see resistors a lot, because we have to reduce the amount of voltage we are taking and all of that. So now this is called a breadboard. Okay, so just like now, whenever you get any of the Arduino sensors and you see GND, it means ground. That is the minus pin. Okay, so that is the minus pin. The minus is like the direction of the flow of current. Okay, so it's like the direction of the flow of current, and every sensor must have positive and negative. Okay, so every sensor must have positive and negative. Okay, now the arduino here has the arduino here has only two GND pin. I don't know if you can see that. There are pins labeled GND, and there are only two. There are only two. Now the plus pin of the arduino is the one next to the GND, which is 5V, is labeled 5V, which is 5 volts. That is the plus or power pin. So when you plug to that 5V, then it's going to is the plus pin, and it's going to give power from that pin. Okay. Now, since we only have one plus pin and we just have two ground pin, we might want to connect so many sensors together. It's just like maybe we are working with this and this. Okay, now like I said, each of these sensors, actuators, all of them have their own ground and positive pin. They have their own negative and positive pin. But then if I'm using more than like plenty sensors, because there are so many things I want to work on, there are so many signals I want to receive, then I have to, that means I'm going to connect more than how many ground and 5V pins. But we just have two of it. We just have two of it in Arduino. Okay. If I connect the ground pin of this, I will also connect the ground pin of this. What are the other sensors? How do I connect their ground pin to the microcontroller? So that is why this is very important. This is just like a board that transfer charge. Okay. Please just leave a comment if you can see the breadboard well. If you can see the breadboard very well, you can identify the pins on the breadboard. Please just leave a comment. Okay, so is necessary. And this has labels too. It's too bright, right? It's actually too bright because of my light. Okay, my light is affecting it, and it's white in color. So okay, can you guys see it like this now? Okay. Okay, fine. So the breadboard can just help me to be able to connect so many pins, because as you can see, all these are pins of the breadboard. All these are pins. Okay, but the breadboard also have its own rules. Okay, now you have to just take note of all of these, because You guys, I don't know if you've tried something like you want to fix a bulb. I don't know if you have like played with electricity to that extent. Maybe you want to fix a bulb and you mistakenly connect your negative to your positive or vice versa. Okay, it will spark. Okay, but this time around, this particular mistake can blow up this board. It can just blow up this board. And you know how much you are buying this board. It can also harm you too. So you need to be very careful when you're dealing with all these plus and minus. Now, this breadboard has its own rules. Now, this side of it is labeled plus. So anything you connect to this line now is positive. The one after it is negative. So anything you connect from here to here is negative. Now, this other end is just like these ones, this positive and negative, they are in horizontal, they are in vertical format like this. They are connected vertically. But this other side is connected horizontally. It's connected horizontally. If I do something like this, let's say I pick this now and I put it like this. I'm very wrong. I'm very wrong by doing this because they are all connected horizontally, which means this particular line where I put this now, which means I'm connecting the four legs of my RGB light together, because this is connected together, this is connected together, these pins horizontally, their pins are connected horizontally. But if I do this, that is when I'm correct, because they are all on independent pins. They are on independent pins. Okay, so that is it for the breadboard. And I'm going to be making use of the breadboard to run a simple project. Okay. Now, I forgot to talk about the analog pins of the Arduino. When we are dealing with sensors, we are dealing with analog pins. That is for some sensors. Some sensors are connected to Arduino digital pin, while some sensors are connected to Arduino analog pin. Okay. Now, what's the difference between these digital and analog pins? The analog pins, the sensors connected to analog pin are taking signal every seconds. Okay, so and they convert the signals they take into analog signals. Okay, but you use digital pins when your sensors are just taking in data slowly from time to time. Okay, so this place is for the analog pin. As you can see, is labeled A0, A1, A2. This is analog pin 0, analog pin 1, analog pin 2 to 5. Okay, so anytime I connect this analog pin, if I connect to this analog pin, that means I'm connecting a sensor to this analog pin actually, and it's going to get analog signal. So first of all, let's see if we can just build a simple project just with these three. Let's see if we can just power on each of these lights. Okay, let's just power on the red, yellow, green. So we are going to see how we write the code and then how we upload the code to this microcontroller. And then the microcontroller keeps running on its own. Okay, so for this, let me just make use of these two. I will not use the breadboard because I'm just handling one something. So I will make use of one GND and others. So like I said, I'm going to connect female pins to this because it is compatible male to female. So I'll just connect female pins to all the four. So I just connected the jumper wires to this now. And there are 4 jumper wires. So now the good thing is that these pins are labeled. Okay, so these pins are labeled and the wires are already connected to it. I can just see, okay, this white is GND. So it's labeled GND. The pin that this white is connected to is labeled GND. Then I will take it, and then this is my Arduino. I will look for GND on this Arduino board. Then I will connect it to GND. See, this is connected now. I just connected it to GND. Now, the next is the brown color is for the red light. Okay, so the brown color is for the red light. That is, it's labeled R. It's labeled R. So I'm going to connect it to an Arduino digital pin so that whenever I give signal to that digital pin, the red light will on, just like what I said. So let me make use of digital pin 2. Please take note of it though. So I just connected the red light now to Arduino digital pin 2. Whenever I give signal from my code, whenever I give signal to pin 2 of the Arduino, red light will on. Now the one following it is yellow. Yeah, it's with yellow wire. So it's labeled yellow. Now I'm going to connect the yellow light to Arduino digital pin 4. Just look for pin 4 here, and this is my pin 4. Okay, and the last one is green light. This is the green light. I'm just going to no, you can use any pin you want though, because it's Ochuku. You can, okay, maybe let me just put it in pin 3. Okay, so those some pins are pulse width modulation pins, but let me not go into that now. So I just used pin 3 so that you'll be satisfied. Yeah, I can use any pin I want. I can use 2, 4, 6, 8, any pin I want actually. Okay, then the last pin I'm going to connect to pin 4. So that is arrow, red, yellow, and green. Red, yellow, and green. So red is 2, yellow is 3, green is 4. So this is connected now. When I run the code, then it's going to work. Okay. So just to be very sure I didn't miss any connection, just to be sure, I'm going to look at it again. Okay, fine. Let me just see if I'll show you guys an example of the code. Please, if you can see the code very well, just leave a comment, please. If you can see the code very well, please leave a comment. Guys, if you can see the code well, please leave a comment. Okay, can you see it now? Can you guys see the code better now? Okay, now, so this is the Arduino IDE. This is the Arduino IDE which we are going to be using. Okay, so I just created a new project, which I can do by just going to File, New, and then create a new project. So immediately you create a new project, these two functions are already there for you. These two functions are already there for you. This is the setup function, and this is the loop function. Now you know that this system is not just something that will run once, it will keep running. That is why the loop function is there for you. So the loop function just keep running your code for you. Okay, you just keep running. When it reaches the end of the code, it starts again. Okay, now what we are going to do is this. We are going to initialize the pins of the Arduino. If you can remember, it was 2, 3, and 4, red, yellow, and green, right? Okay, now this is what we are going to do. Int red is equal to, our red was 2. Are you guys there? So int red is equal to 2. That is pin 2 of the Arduino. Red is pin 2 of the Arduino. Now, yellow is equal to 3. Yellow is pin 3 of the Arduino. And green is equal to 4. Green is pin 4 of the Arduino. So now, this setup, the setup function is just where you're going to like initialize your sensors. Okay, some sensors are inputs while some are outputs. Okay, the actuators are outputs and the sensors are always inputs. Sensors are not output because they are receiving something, they are receiving a signal, so they are always inputs. Now there is no sensor connected here. All I just have is an actuator, which is the RGB lights. So let me just initialize it. Just take note of the keywords I use and the syntax. That is just what matters. And Arduino is case sensitive, please. Whenever you see me use capital letter output, it's case sensitive. If I use small letter, it's not going to work. Okay, so I just initialize the pin just to tell the system, just to let the system know that red is pin 2, right? That is the variable red is pin 2. So just to let the program know that 2 is output, pin 2 is output. So the same thing with others, the same thing with the yellow and the same thing with the green. Okay, here should be yellow and here should be green. Now this is the function that keeps running. Okay guys, so what I have to do is digital write red high. Now what this particular code means is that it should hide the red pin. Now sending a high signal means on it, that is giving it a high trigger. It's going to give power to that particular pin, and once power is given to that particular pin, then what is connected to that pin will on. Okay, so that's why I'm using digital write red high, which means I'm telling pin 2, red is pin 2. I'm telling it to give power, to give a high potential to pin 2, and it's going to give power to pin 2. So once power is given to pin 2, the element connected to pin 2 will turn on. Okay, now then I'm going to say delay 1000. This means after this particular code runs, delay as in just delay for 1 second. 1000 is 1 seconds. 1 second is 1000 milliseconds. So it's counting with milliseconds. This is 1 seconds. So just delay for 1 second. Then turn on the yellow light. That is the next command I'm going to give. So I'm hiding yellow now. And if I want, okay, let me just do it like this. So then I'm hiding yellow now. Now delay for another 1 second. And then high green. So I just wrote the code now. Okay, now the next, since I'm done writing the code, the next thing I'm going to do is to connect this code, transfer this code to the microcontroller, so that whenever power is given to the microcontroller just runs on its own automatically. And that is what I'm going to do next. So this is it. This is our recent connection now. So in order to transfer my code, to this, the Arduino board comes with a code. So this is how the code looks like. This is how the code looks like. I'll connect this particular cord to this place. That is this end of the cord. I'll connect it to the Arduino board. It's connected now. Okay, then I will connect the other one to the USB port of my laptop. Just the normal USB port of the laptop. So once I connect it that way, the Arduino will be powered, because the laptop is going to give out power to the Arduino right now. Okay. So if you notice, the Arduino just turned on. Now I've connected my Arduino to the system. The next thing is to transfer my code. This icon is for transferring my code. But first, let me just compile to make sure that okay, so just to make sure that there is no error in my code. Okay, so let me just I have to save the file before I'll be able to do anything. Let's say traffic. Let me just save it to traffic. Then I'm compiling it now. As you can see, this is the progress of the compilation. This is the progress. So I'm just waiting for the code to compile. Okay, great. So as you can see, there was no error in the compilation. It says done compiling. Assuming there is an error, it would have just, okay, let me like remove a semicolon here so that you will see how it will show when there is an error. So I'm compiling again. As you can see, there is a warning here. There is a warning. There's an error with this particular line. So let me just add this back. So I'm sure that everything is okay. Then next thing is to go to tools, because like I said, Arduino has so many types. Okay, we have Arduino Uno, Arduino Nano, Arduino Mega. So, and we need to choose the particular Arduino we are working with here before we transfer our code to the Arduino. It's just the Arduino IDE. It's just the Arduino IDE, because that is where everything is for you. The upload button is, and all of that. So it's just the Arduino IDE that can be used to upload codes to the Arduino. Now let me just choose board. As you can see, this is the board, and then I have to choose. Is it, as you can see, there's so many boards here. Is it Arduino Uno? Is it Arduino Uno? Is it Arduino Nano? Is it Arduino Mega? Arduino Leonardo? Or which one am I working with? Then I have to tick Arduino Uno, because I'm working with Arduino Uno. Then each of these Arduino have ports, have their own ports. Okay. Sorry, I didn't like put the pin very well. I didn't connect the USB to Arduino very well, but I just corrected myself. So each of the Arduino has ports. Now, as you can see here, this is COM9. That is the port of this party. Once you connect your Arduino to the system, when you go to Arduino IDE, then you'll be able to see the name of that port on the Arduino IDE. So the name of this port, this particular So the name of this particular Arduino, the port of this particular Arduino I'm using is COM9, communication port 9. So I have to tick it just to let it know that I should transfer this file to port 9. Okay. Then this is the upload button, and I'm going to upload. So guys, this is it. I just uploaded and it's working now. So let me just connect it again so that you will see. So the red is on. After 1 second, the yellow. After another 1 second, the green came on. Just like the program we wrote. Okay. Then, okay, let me just say, so that I will give you more time. In my code, let me just increase it to 3 seconds. So that after 3 seconds, each of them will turn on. So let me upload it again. Anytime I change something in my code, I will upload it again. So the red is on now. After 3 seconds, the yellow. After 3 seconds, the green came on. So that is because this is the command I gave it. Okay. But now let's say, assuming I want them to turn off before the next. Maybe I just turned on green and I want green to turn off before red. Okay. Then I would just, okay, the opposite of high is low now. So I'm going to just send a low trigger. I'm going to send a low trigger to the board. So that means after 3 seconds, before I turn on green, I have to turn off the last one we worked with. Okay, so the last one was yellow here. Then I will just turn off yellow by using the low trigger. Same with this place. The last one was red. I will turn off red. It's case sensitive, remember? I will turn off red by using the low trigger. Okay. Then 3 seconds. 3 seconds after the green turned on. 3 seconds after the green turned on, I will turn it off again. So that red can then, because like I said, it's loop. Once it run the code and go down, it will start again. Okay. So it will give a low trigger to green, yeah, before it goes back to red. So maybe let me just increase this to 5 seconds, just for us to see it accurately. So I just uploaded. Now this is it. The red is on now. After 5 seconds, the red turned off, the yellow is now on. After 5 seconds, the yellow went off and the green came on. After 5 seconds, the green is off, the red is on again. So this is just like the traffic light system we know. Okay. So just leave a comment if you understand up to this point. If you have any questions, then you can ask a question in the comment section. Please, if you have any question, just leave your question in the comment section. Or you can just let me know you understand everything. Like I said, yeah, you can use any type of Arduino for your project, just any type of Arduino. But the designs are not the same. Just like the Arduino I have here. The designs are not the same. You might have to learn how the other kind of Arduino you are using works. So you might have to learn how the other kind of Arduino works. Just like now, I'm very familiar with the digital pins, the analog pins. When you get another kind of Arduino, you will still try to understand that one too. So you can use any type of Arduino for your projects. And also, Arduino varies based on the size too. Just like Arduino Nano. Arduino Nano is small. So it's small and portable. In case you don't want to use that is a little bit bigger, you can use Nano, which is very small. Okay. So later I'm going to upload this particular code to my GitHub, and then you can be able to just look into the code, try to understand. And if you have any questions, you can please ask me. Okay. Please, if you have any questions, you can ask me. I'm done. Okay, let me confirm the email. I've not really seen the email though. I've not seen the email. Okay, so since there is no question, thank you for your time. So I'll be off now. Yeah. Um, Kosisochukwu Mezwe, please, if you are following me on any social media platform, just chat me up there instead. Just chat me on any social media platform where you're following me. Then I will reply, please. Okay, guys, so that will be all for today. Next time, then we will have to build a more complex IoT project. Today, we didn't use sensors. So next time, we'll have to make use of sensors just to build a more complex IoT project and see how it works. Okay, thank you. If you have any questions, you can ask me on any of my social media platforms. If you're unable to ask here, you can still ask me on any of my social media platforms. Okay, thank you for your time. Good